Hello and welcome everyone. Thank you for visiting my channel, Just a Guy Who Likes Math, and today I'm going to show you how to get the number of trailing zeros in n factorial. Now for this, obviously you need to know what n factorial is. N factorial of any number, I'm just going to do it real quick, so just bear with me. It equals n times n minus 1 times n minus 2, so on and so forth, all the way back to down to 3 times 2 times 1. So basically n factorial of any number n, it has to be a whole number equals n times equals the number itself times the previous number times the number before that number times all the way down to 1. For convenience sake, we just do 0 factorial equals 1. And we also, the rule is that factorial of a negative number is undefined. And as per the rule, n factorial equals n times n minus 1 factorial for any number n that's greater than equal to 1, any natural number. Okay, so let's get back to the question. Number of trailing zeros in n factorial. So what you do to get this is this. To get the number of trailing zeros in n factorial, what you do is n divided by 5 raised to the power of 1 plus n divided by 5 to the power of 2 plus n divided by 5 to the power of 3 plus, and you can see so on and so forth, till n divided by 5 to the power of k. Now a couple of things you should know here. What is k? That's one of the first things you should know. So k, as you can see, this is a series that goes on. So k is obviously going to be a natural number. But so k is a natural number such that 5 to the k is less than n. Basically what I'm trying to say is that 5 to the power of k cannot be greater than n. Okay, I hope that made sense. I'm going to do an example right after this, so it's going to make more sense. But also, what you also have to do is take only the quotient. And if you don't know what this function is, it's like, I don't know if you guys are into programming. It's like a math.min function. So basically, let's say you have a number 3.6. You don't round it. What you do with this kind of function is just take the bottom. Just take the quotient, so there's just 3. Okay, hope that made sense. Let's use an example to make it a little easier. Find the number of trailing zeros. I'm just a little lazy. I'm going to say TZ. Find the number of trailing zeros in, let's say, 38 factorial. Now, obviously, another way to do it is just do 38 times 37 times 36 all the way down to 1. That just seems a little unreasonable. So we're just going to use the formula. And yes, let me plug in the formula. This equals n divided by 5. So I'm sorry, n equals 38. So 38 divides by 5, and just the quotient of it, plus 38 divided by 25, just the quotient of it. And I would have gone so on and so forth, but however, I did say one of the conditions was 5 to the power of k has to be less than n. So if k becomes 3, this becomes 125, which is greater than 38, so you can't do that. So only these two for now. Okay. So as you can see over here, 5 times 7 equals 35. So we just take the quotient, which is 7. And 25 times 1, obviously, has to be the quotient, so 1. So the number of trailing zeros equals 8. Okay, perfect. I think we got this. And I guess a really cool thing that I could find out is why we use the number 5. So let's just take into example a number. Let's say it's 8,000. Whoops, there it is, 8,000. So what is a trailing zero? A trailing zero is just 8 times. This can be represented as 8 times 10 times 10 times 10. Now the 10 can be represented by 2 times 5, right? I guess we all know that. And if you do in a factorial, which I talked about here, in a factorial, let's say n factorial. Yeah, I'm just gonna represent it in a different way. 1 times 2 times 3 times 4 times 5, and so on and so forth. Is that correct? So there's a 2 over here. 4 is actually 2 2s, 2 times 2, and there's first 5 is over here. And if you go on, there's 8, which is actually 3 2s, and there's another 10, which is a 2 times 5. So basically, the number 2 appears way more often in n factorial than 5 itself. And you can only get a 10 by getting 2 times 5. So the number of 10s can only be the number dependent is only dependent on the number of 5s in this n factorial, and that's why we use the number 5. I hope all of this made sense. I'm just going to give you, I guess, some time to look it over. Okay, one thing I did want to talk about, I'll talk about on the next page. So we just use, trailing zeros, and we used the prime number 5. We could actually use any prime number. We could use the same formula, just modify it a little bit. So I guess the new topic would be find the powers of prime p in n factorial. It's kind of similar, and maybe some of you have already guessed the formula. The way to get this equals n divided by p to the 1 plus n divided by p to the 2 plus n divided by p to the 3, so on and so forth, till n p to the k. Again, k is a number. K can be the highest number in this kind of series, such that p to the k is still less than n. Let's do a quick example. Find the powers of prime 3. Let's say let's do the same 38 factorial. So basically, what you do is 38 divided by 3 plus 38 divided by 9 plus 38 divided by 27, and this is 27 is as high as can go because this is 3 cubed. 3 to the power of 4 equals 81, and I can't really use that because 81 is greater than 38, and I'm also doing just the quotient for this. So let's see what this is. 36 is 12, so 3 times 12 equals 36. That's as much as you go from here. 9 times 3 is 36. That's going to be plus 3. 9 times 3 is 36. As much as can go, the remainder is 2. Now 27 obviously goes only once. So the powers of prime 3 in 38 factorial will be 12 plus 3 plus 1, which equals 16. There we go. That's how you get the answer. Okay, I hope all of this made sense. Thank you for your time, guys. If you do have any questions, feel free to comment down below. If you do want to subscribe or like this video, I do appreciate it. But until next time, peace out.